Hello, my name is Lydia and I'm an applications engineer at Theta Technologies. I'm going to show you how to do a nonlinear resonance test using the RD1T2. So the aim of the nonlinear resonance test is to put sound energy into the part and see what the frequency response is. So to do this, we use a laser to detect how the part vibrates across the different frequencies that we put in. So the laser is detecting the movement of the part. So in order for the laser to detect the frequency response of the part, we need to use a bit of reflective tape for the signal to bounce back up into the laser. Vibration modes are patterns of energy, so high and low amplitude throughout the part, and the specific area and amplitude of the vibration mode will vary depending on the natural frequency of the part. So we aim to just place this reflective tape where we expect to be the highest amplitude for the best frequency response measurement. So in order to obtain the best frequency response of the part, we want to allow the part to move and be able to vibrate as much as possible without distorting the signal. So we'll work with you to develop a fixture that will hold the part in place enough to stop it moving too much, but still allow freedom for excitation. So now we have a fixture, we can place the part within the RD1. So in order to get the frequency response, we need to move the laser so that it's pointing on top of the reflective tape. We need to do this for the first test as we set it up, so we can use the touchscreen controls to move the laser into the correct position. The RD1 is a rapid go, no-go system, so all of this setup only has to be done for the first test. From then on, you can just click load and it will load all of the previous settings. If you use barcodes to track your manufacturing production, RD1 can come with a scanner so that you can just scan the barcode and it will upload all the part IDs and test IDs needed. Before we click go, we just do a final quick check to ensure that the laser signal is good. We can see that on the touchscreen. Once happy, we can run the test. Once the test is running, you might be able to hear the frequencies that are being excited in the part. You can see the velocity at which the part is moving. You can also see a progress bar, so you can see how long it's going to take until the test is finished. We can expect the test to take less than 1 minute. The results are available to see straight away. Theta's software analyses the frequency response and looks for nonlinearities in the part. This enables us to know whether there is a flaw or not within the part. You can find out more about how our technology works or about understanding our results data by looking on our website or contacting us at info@thetandt.com.